In Chapter 16, we're going to begin combining different random variables to find the probability of certain events. When we're talking about a random variable in general, we'll refer to it with a capital letter, say capital X. For instance, let's say we're talking about rolling a die. When we're talking about a specific instance of a random variable, say rolling a 1 on that die, we refer to that as a lowercase x. Now, there's two types of random variables, and we should recognize these terms way back from Unit 1 when we were talking about types of data. There are discrete random variables, and those are random variables that take on countable values, such as the number of eggs a hen can lay, number of touchdowns scored in a football game, etc. And then there's continuous random variables, okay, which can take on any numeric value within a range, such as the amount of milk that a cow can produce, the height of a person or a tree. So discrete is associated more with like countable data. Continuous is associated with measured data. When we're talking about finding the expected value of a random variable, we could also just refer to this as the mean. We would find it by multiplying each individual value of that random variable by its probability. Then we would sum all of them up. That's what this big E here means. So it's the sum of x times p of x for each particular value of that random variable. Okay, when we refer to the expected value, we would write it like this, capital E with x inside parentheses, or we could use this symbol mu, which represents the mean. So for defining the random variable, there's really two options we can go with. We can go with the probability of the repair occurring, or we could go with the cost of the repair. Now, considering they're asking for the expected cost of the repair, let's plan out that as the expected variable. So we can see this as the probability model for this situation. There's really two outcomes that they go through. Either they recharge this coolant and recharging it works. That's a $60 cost and it occurs 75% of the time. Or that doesn't work, in which they charge an extra $100 plus $40 for labor. That brings us to a total of $200, and that's going to occur the other 25% of the time. So the random variable is the cost. Okay, that's in red up here. Okay, I just wrote in the situations that led to those costs. And then we have the probabilities associated with those random variables. We also want to check to make sure that the probabilities add to 100%. Now in part B, when it's asking what's the expected value of the cost of this repair, this is the same thing as asking what's the mean expected cost for this repair. So to find this, we're going to find the sum of x times p of x, which means we take each individual column and we multiply the repair cost times the probability of that cost occurring. Okay, and we do the same thing for each individual outcome. So for this problem, we're going to do 60 times the 75% of the time that you'll have to pay $60, and then add 200 times the 25% of the time that you'll have to pay $200. Okay, and that results in an expected cost or a mean cost of $95. Now, just note that this isn't an actual possible outcome. You'll never pay $95. It's just the expected value for this repair, and that leads us into part C. Okay, what does this mean in context? It means that if many people were to come into the repair shop with this problem, on average, they would pay $95 for this repair. No one would actually pay $95. They would either pay $60 if recharging the coolant works, or they would pay $200 if it didn't work. But if we averaged all their repair bills together, they would average about $95. So the expected value is the mean. That's the center of our random variable, the center of our probability distribution. Now we're going to move on to the standard deviation. The standard deviation, if we think back to Unit 1, is telling us how spread out our distribution is. Okay, the actual definition was the average distance from the mean of our data. So it's telling us, if we look at our full probability distribution, how spread out is the distribution from the expected value, from the mean. So to find the standard deviation, we need to find the variance, which is just one of the steps that we need to find. And the reason being, is that we square all the values when we find standard deviation just to make them all positive, otherwise they would cancel out. So the equation for variance is, again, sum of x minus the mean squared times the probability. So for every column, we take that individual x value, we subtract the mean, square that value to make it positive, multiply it by the individual probability for that value, do that for every column and add them all up. Standard deviation is just the square root of the variance. Our random variable for this problem is the profit that this owner should expect to make on this horse. So the horse is running in 2 races, and either it's going to lose both races, it's going to win both races, or it will just win one of the races. So these numbers here, the owner spent $20,000 on the horse. If it loses both races, it's only worth $10,000, in which case he's lost $10,000. If it wins one of the two, it's now worth $50,000, so he makes a profit of $30,000. If it wins both races, it's worth $100,000, so he makes a profit of $80,000. So first step, we have to figure out what these probabilities are associated with each of these outcomes. So these are the probabilities as to how we got them. Winning both, there's a 20% chance that it wins the first, a 30% chance that it wins the second, 20% times 30%, 0.06. Losing both or winning neither, if there's a 20% chance that it wins the first, it means there's an 80% chance that it loses. Same thing with the second, 30% it wins, so 70% chance that it loses. Now, in the middle, at this point, once we have these two values, we can just figure out what's in the middle by adding those two together. We'd get 62% and subtracting from 100, because this needs to total 100%. The last way we can do it, which is a little more complicated, but it's good to know how to do it, winning one, which means it's either going to win the first, 0.2%, and lose the second, all right, or, so plus, it's going to lose the first, 0.8, and win the second. Okay, and if we take those, we add them together, we're going to get 38%. Now, using this distribution, go ahead and try to find the expected value and the standard deviation. Remember, expected value is x times p of x. We're multiplying the profit times its probability for each column, add them all up. Once you find that expected value, or the mean of this random variable, we take that mean, take each of these profits, subtract the mean, square it, multiply it by the probability. Do the same thing for each column, add those all up. That gives you the variance, square root the variance to get the standard deviation. So for the expected value, you should have gotten $10,600. That's the mean profit that the owner should expect to make on this racehorse. Again, that's not a possible value. The only possible values for this racehorse are losing $10,000, making $30,000, and making $80,000. So only if he were to do this over and over and over again many times, it would average out to making $10,600 in the long run. Now the variance, this is the necessary step to finding standard deviation. You would get this huge number, 669,640,000. This is in square dollars. We don't really understand variance for that reason. It's always in square units, but again, it is necessary to find it on the way to standard deviation. Square root that number to get the standard deviation, $25,877.40. It makes sense that there's a large standard deviation for this problem because there's a pretty wide range of outcomes. The owner can have a wide range of outcomes here. He can win $80,000, he can lose $10,000. So again, there's a pretty big spread here in our outcomes.